Let's practice solving some quadratic equation application problems dealing with the area of rectangles together. In total, there are going to be 4 practice problems that we're going to do together. For each of them, let's go ahead and start off by writing a quadratic equation. Then we're going to go ahead and solve for the dimensions of the rectangle. So we're going to find the length and the width, or the base and the height of each of them. All right, let's get started with number 1. For number 1, we see that we have a rectangle that has an area of 21 square meters and has a length that is going to be 4 less than whatever the width is. Let's start by identifying what we know and don't know. All right, so we're given the information that the area is 21 square meters, so we can go ahead and write that in. We also know that the length is going to be 4 less than whatever the width is. Now, we don't know the width, so I'm going to go ahead and use the variable x to represent how long the width is, but the length is going to be 4 less than whatever that is, so we can use the expression of x minus 4 in terms of that length there. So I'm going to say that's going to be x minus 4 meters, that's the length, and the width here is going to be x meters. We don't know what that is either. Drawing a quick sketch here, we know the area is 21. The width is going to be x, and the length is going to be x minus 4, so that's going to be the shorter side. Remember, to find the area of a rectangle, we have to multiply the length and the width together. So the area here is going to be 21. The length here, we're going to go ahead and change this to this x minus 4, because that's how long that is. And the width here is going to be x. We're going to multiply x by it. Now, we don't need to write the parentheses, but you can go ahead to write it if you would like to. Let's go ahead and solve this, because right now this is a quadratic equation. Let's go ahead and distribute this x to the x and the x to the minus 4 here. If we go ahead and do that, we're going to get 21 is equal to 1x squared, or just x squared, and then it's going to be minus 4x. Then to put this into standard form, we can go ahead and take away 21 from both sides of the equation. And if we do that, we're going to have 0 is equal to this x squared minus the 4x, and then minus 21. Now at this point we have a quadratic equation, and we should go through the 4 different methods, like solving by square roots, or factoring, or completing the square, or the quadratic formula. I think if we go ahead and see if we can factor this, for x squared I'm going to put x and x, and then for the negative 21, if we do a negative 7 and a positive 3, I think this is going to work nicely. So if we multiply across here, that's going to be negative 7x and positive 3x, and that's going to get the negative 4x in the middle. So going ahead and factoring this, we can say 0 is equal to, I like opening up these binomials here. One of them is going to be the x and then the minus 7. Those are my outers. And then we have the x and then the plus 3, and those are our inners. So you can go ahead and FOIL this out to see if it works, just to double check. And then what I'm going to do here is just say, okay, each of these has to equal 0, right? So for this one over here, what value of x would make this 0? Well, if x was negative 3, then this whole thing would equal 0. And then over here, if x was equal to a positive 7, then this equation would also be true. Now, can x really equal negative 3? Well, I don't think so, because if we plug in negative 3 here and negative 3 here, we're going to get dimensions that are negative, which can't be true for this rectangle. And what we're going to do then is say that this is not a solution we're going to consider, but we will take a look at this 7 here, because if we plug in this 7 where this x is, that would be 7, and we plug in this 7 over here, that would be 7 minus 4 is 3. 7 times 3 does equal 21, so we do like this other solution down here. And so while we have 2 solutions in this particular application problem, we only care about this positive one because we're talking about geometry. And so plugging in this 7 into the length here, 7 minus 4, that's going to equal 3, so that's going to be 3 meters. And then if we go ahead and take this 7 and plug it into the width expression, that's just going to be 7 meters. Let's check out number 2. For number 2, we have a rectangle that has an area of this 70 square inches, so that's going to be the area, and has a length that is going to be 4 inches less than twice whatever the width is. All right, let's start by labeling some things here. First off, we know that the area is going to be 70 square inches. And then for the length, remember that is going to be 4 inches less than whatever twice the width is. So if we don't know what the width is, we should go ahead and say that's going to be x inches. I'm going to use the variable x, but feel free to use a different one. As for the length, we know it's 4 inches less than twice whatever the width is. So the width is x, so twice what that is going to be 2 times x, and it's 4 less than that, so we're going to take away 4. So this would be the expression that would represent the length of this rectangle. Sketching this out, we have the area, which is 70. The length I'm going to put over here on the side is going to be 2x minus 4, and the width is going to be x. So it might not be drawn to scale, but that's okay. Remember, our formula is area equals length times width, so let's go ahead and substitute the area is going to be 70. That's going to be equal to the length, which is our expression of 2x minus 4. That's going to multiply by the width, which we know is equal to x, or is being represented by x. So here is our quadratic equation. Let's go ahead and see if we can write it in standard form so we can solve it. Let's go ahead and take this x and distribute it to both of these terms on the inside of that linear binomial. And so we have 70 is equal to, then x times 2x, that's going to be 1x times 2x, which is 2x squared. And then we have 1x times negative 4, which is negative 4x. Next, let's go ahead and put it in standard form by subtracting 70 from both sides. So we can go ahead and set this whole thing equal to 0. And so when we do that, we're going to get 0 on the left side. That's equal to 2x squared minus the 4x minus the 70. So now we have our quadratic equation in standard form, so let's see if we can maybe solve this whole thing. First though, we can make our lives a little bit easier if we notice that all of these terms have a common factor of 2. So maybe we can factor that out so the rest of it is a little bit less to deal with. So if we factor out a 2, we're going to get x squared minus the 2x minus 35. So if we're going to solve this by factoring, which I think we might be able to here, at least we have some smaller factors to deal with because that 2 is not going to really affect anything. Alright, so looking at this trinomial on the inside, I don't think we can solve by square roots because that b value is negative 2, but let's see if we can factor. Now let's see, we have x squared, so I know x times x is x squared, and then for the negative 35, I'm thinking maybe negative 7 and positive 5, that gets you negative 35 if you multiply, and if you multiply x times negative 7, that's negative 7x, plus 5x, that does equal the negative 2x in the middle, so we like that. So let's see here. We're going to have 0 is equal to 2 times, let's go ahead and put 2 of these binomials here. On the outers, I'm going to put this x and then minus 7. And on the inners, let's go ahead and put the x and then the plus 5. Alright, so let's see what makes this right side equal 0. Well, the 2 has no impact on that. That 2 is just going to be 2. But what makes this linear binomial equal 0 is the opposite of 5. So if x was negative 5, then this whole right side would become 0. And if we look at this x minus 7, if x happened to be positive 7, then that would become 0 and the whole right side would become 0 as well. So we have these two solutions, but if we take a look at this x equals negative 5, we're not going to have a negative length here or a negative width, so we're going to go ahead and ignore that for now. However, when x is equal to this positive 7, that seems to check out okay. So that 7 would go here, that would be a positive 7 inches, and that's okay. If 7 goes over here, 2 times 7 is 14. 14 minus 4 is 10, so 7 times 10 does equal that 70 that's supposed to be in the middle for the area. So putting this together, we can go ahead and take this 7 and substitute right here for the length. 7 times 2 is 14, minus 4 is 10, like we just said. That would be 10 inches for how long this rectangle would be. And then if we go ahead and take that 7 and then substitute it for the width here, 7 is just going to be 7, so that would be 7 inches. So hopefully that makes sense and you do get 70 square inches for the area of this rectangle. Here is number 3. For number 3, a rectangle has an area of this 66 square inches. It has a length of this x plus 7 inches and a width of x plus 2 inches. So this one's nice because they just give us the expressions that we need. So the area here is going to be 66 square inches. Looks like the length here is going to be this x plus 7 inches. So we don't need to go ahead and think too much because they just tell it to us. And the width here is going to be x plus 2 inches. Seeing this visually, we know the area is going to be 66. I'm going to put that on the inside here. And then the length, I'm going to go ahead and put that as x plus 7 over here. It doesn't really matter, but hopefully this is a little bit more to scale, and this would be x plus 2 for the width. For the area of a rectangle, it's length times width. The area we know is going to be 66. Let's go ahead and write that. The length, we're going to write this binomial of x plus 7, and the width here is going to be the binomial of x plus 2. Now that we have a quadratic equation, let's see if we can write this in standard form, distributing this x to this x and then this x to this 2 first. Let's see what we're going to get. Essentially, we're just foiling here, so whatever you want to call that. We have 66 is equal to, so 1x times 1x is 1x squared. Then we have x times 2, or 1x times 2, that's going to be a positive 2x. Then we're going to go ahead and distribute this 7 to this 1x and then this 7 to this positive 2. So 7 times that 1x is going to be a positive 7x, and then 7 times 2 is going to be 14. Okay, so after we FOIL, we should see two like terms in the middle to help us get us our b coefficient or b value. So we have 66 is equal to 1x squared, and then that 2x plus 7x, that's going to be 9x, and that's going to be plus 14. Next, let's see if we can get this in standard form by setting it equal to 0. We can do that by subtracting 66 from both sides. And when we do that, we're going to get 0 is equal to this 1x squared plus the 9x, and then minus 52. Now I don't want to solve by square roots, but maybe we can try factoring here. So let's see, for x squared, I'm going to go with 1x and 1x. That gets you x squared. For 52, I'm thinking maybe 1 and 52. No, maybe 2 and 26. I don't think so. Maybe 4 and 13. If we go with a negative 4 and a positive 13, I think that's going to work nicely because 13 times 4 is 52. And then we have a negative 4x if we multiply and a positive 13x. And negative 4 plus 13 does get you positive 9, so I think those are going to help us with factoring. So let's go ahead and write this as 0 is equal to, and our two binomials here are going to be on the outers x minus 4, and then on the inners we're going to have x plus 13. Doesn't really matter in this case because a is equal to 1, but this would be the factored form for this quadratic equation. Now, what makes this equation equal to 0? Well, if we look at this linear binomial over here, we can say we know that if x happened to be negative 13, that would cause the right side to equal 0. And we can also say, looking at this binomial, that if x was equal to positive 4, that same thing would happen. So those are the two numbers that would make the right side equal 0, which would match the left side. Now, if we were to use this negative 13 for x, we can see that this would be negative 6, and over here this would be negative 11. And a negative 11 times negative 6 does get you positive 66, but we can't have negative dimensions here, so we're going to ignore that solution even though we got it. However, if we do use this x equals positive 4, that seems to work out just fine. If we take this 4 and substitute it here, we get positive 11 and positive 6, and that helps us get our actual dimensions. And so substituting this 4 in for the length, 4 plus 7, we just said was 11, so I'm going to go ahead and write 11 inches. And then if we go ahead and take that 4 and then substitute it in over here, 4 plus 2 is 6, we can say the width here is going to be 6 inches. These would be the dimensions for this given rectangle. Let's check out number 4. For number 4, originally there was a rectangle with dimensions of 3x minus 2 meters by x plus 6 meters. Then a rectangle with the dimensions of x minus 1 meters by 2x meters was cut out from this rectangle. We're trying to take a look at the area that is left over. That area that's left over after cutting out that smaller rectangle is 103 square meters. We're going to go ahead and find out the dimensions of the smaller rectangle that was cut out from the big rectangle. For this one, maybe let's start with drawing a picture first. Here is our bigger rectangle that has the dimensions of 3x minus 2 and x plus 6. And here is a smaller rectangle that has the dimensions here. I'm going to call this one x minus 1 and this other dimension of 2x. Now remember, this rectangle over here is going to be cut out, and we're trying to figure out the area of what is left over, or use that area rather. And so this 103 square meters that we're talking about is the area left over after cutting out. So hopefully you can see visually that this 103 square meters is this shaded part that you can see down below. To find the area of the big rectangle, we would go ahead and multiply the length and width, and that would be this quantity of 3x minus 2 multiplied by the quantity of x plus 6. So that would get you the area of the big rectangle, or the expression of the area of the big rectangle. As for the small rectangle, the length times width, or the area of that one, would be represented by the expression the quantity of x minus 1 times this 2x, so that would get the area of the small rectangle. And then try to recall that after we subtract the area of the smaller one from the bigger one, the area left was going to be 103 square meters, so let's just go ahead and label that as 103. That's going to be the area of the shaded region. So for the area of the shaded region, that's going to be 103. Let's set that over here, and that's going to be equal to the area of the big rectangle minus the area of the small rectangle. All right, let's go ahead and see if we can simplify this equation just a bit, because there's a lot going on. If we go ahead and FOIL out this first set of binomials, that's going to be right over here for the big rectangle. If we multiply 3x times this 1x here, that's going to be 3x squared. Okay, then we go ahead and take this 3x and multiply it by this 6. That's going to be 18x. Now I'm going to try to combine the middle term here. We have negative 2 times 1x, which is negative 2x. So that 18x minus 2x is going to be a positive 16x. Okay, After we do that, let's go ahead and multiply this -2 times this +6, and that's going to be a -12. So foiling it out, that's going to be the trinomial that we get here. And now let's go ahead and see if we can subtract the area of that smaller rectangle. So let's go ahead and figure out the area of this smaller rectangle. Let's go ahead and start by distributing that 2x. So this 2x times this 1x, that's going to be 2x squared. So I'm going to go ahead and write 2x squared. Make sure we put parentheses here because we're subtracting this whole expression. 2x times this -1 is going to be -2x, so let's go ahead and put that just like this. Now, if we're taking away this entire expression, which is the area of that smaller rectangle, we're going to go ahead and distribute this -1 that is in front of this parentheses to both of these terms. So if we distribute that negative, we're going to get minus this 2x squared and then plus 2x at the end. All right, now let's see if we can clean this up just a little bit here by combining some like terms. So let's get a little bit more space. If we go ahead and combine the x squared terms, we have 3x squared minus 2x squared. That's just going to be a positive 1x squared. Then we have this 16x plus 2x. That's going to be a positive 18x. And then we have just a constant term of -12, which doesn't have any like terms right now. So let's go ahead and just take away 12. All right, so it's almost in standard form. We can go ahead and take away 103 from both sides. Let's set this whole thing equal to 0. And when we do that, we're going to get 0 is equal to this 1x squared plus 18x and then minus 115. Now, I don't think we can solve this one by square roots, and we should maybe try to see if we can factor. We have 1 for a, so that's kind of nice. So we're just going to have 1x and 1x. And then for 115, well, it is divisible by 5, right? So 5 times 23 is 115. Let's go ahead and say if we have a -5 and a positive 23, that does equal -115 if you multiply them. But also, if we multiply across, it would be -5x and a positive 23x, which would combine to a positive 18x. So this is factorable, which is nice. We have 0 is equal to, let's go ahead and open up our binomials here. Our outers, we're going to go ahead and say this is going to be x and then -5. And then for our inners, we're going to have x and then plus 23. Again, if you want to go ahead and FOIL this out, feel free to do so, but pretty sure this is going to work out okay. And we have our binomials, which is nice to help us figure out what makes this equal 0. For the linear binomial on the left, we're going to have x is equal to -23, or the opposite of 23. And over here, we're going to say x would equal 5, or the opposite of -5. Now try to remember that we are looking for the dimensions of the smaller rectangle that was cut out. So we want to know the length and the width of this smaller one. If we take a look and use this -23, that's going to get us negative dimensions, which is not what we're looking for. However, if we use this x equals 5, we're going to get positive dimensions, which is what we are looking for. So let's go ahead and take this positive 5 and plug it into both expressions for the length and the width. And so if you take this 5 and we substitute it in for the length maybe here, this would be 5 minus 1, which is going to be 4. I think we were talking about meters here, so this would be 4 meters. I'm going to call that my length. And let's go ahead and take this width. Let's use this 5 and plug it in here for the width. That's going to be 5 times 2. That's going to be 10, so that's going to be 10 meters. So the dimensions of that smaller rectangle are going to be 4 meters by 10 meters. Alright, so there you have 4 different practice problems dealing with some applications of solving quadratic equations, finding some missing dimensions of rectangles. Hopefully you found the video helpful. If you did, please consider giving the video a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing, and I'll see you in the next one.